Hello, this is Professor Evans. This video is for the students in COP1000C, which is Intro to Programming Concepts at Valencia College in Orlando, Florida. In this video, I'm going to go over Unit 2 from our MindTap textbook, which is Basic Elements of C++. Some of the learning objectives for Unit 2 are shown on the screen, and I'm going to do some examples today that will help you to understand how to connect these learning objectives to writing your computer programs within C++. So some of the things that we're going to work on are things like identifying basic components of a C++ program, classifying simple data types using arithmetic operators. We're going to create assignment and input statements and use variables within our statements. We're going to differentiate between operators, develop output results using output statements. We will talk about how to identify syntax errors and debugging techniques, distinguish the proper structure of a program, define basic programming terminology, and we're going to write 3 basic C++ programs within this video today. So I'm going to switch over to my compiler so that I can begin our first program. In this program, I'm going to begin by writing the program objective. It always helps to keep your code focused by writing down what you're trying to achieve at the top within a comment. So our first program for this video is going to ask the user to enter 2 numbers and output the sum of those 2 numbers. So my program objective is very simple. I'm going to start with a simple problem and then work up to some more complex problems as we go throughout this video. So after I'm adding the program objective to the beginning of my program, I'm also going to add some lines to help me clarify my thought process on how I need to write this program. For example, when we write a program, we need to consider our inputs, our outputs, and how we're going to derive the output based on the inputs. So within my comment, I'm going to write down what my inputs to this program should be. Based on the program objective, I need 2 inputs. I'm just going to call them num1 and num2. I'm going to have one output, which is going to be the sum. Next, I'm going to write down the process, which is going to be my algorithm or my methodology for determining how the output will be generated based on the inputs. In this case, I can see that my sum must equal num1 plus num2. So my process is going to be the way that I am going to generate the outputs once I receive the inputs from the user. So that's going to conclude my header for this program, where I've clearly shown what I am trying to achieve with the objective, what my inputs are, what my output will be, and then how I'm going to get that output. The next 2 lines allow us to the next 2 lines allow us access to input and output functions. So in most of our C++ programs this semester, we're going to have to ask the user to enter data and then display data back to the user on the screen. In order to do that, we have to include the next 2 lines to access those functions. So input and output functions include things like read from the user and write to the user on the screen. So in order to have access to those input functions and output functions, we're going to have a statement called #include, and we're going to type in IOStream within the brackets, and then we're going to have the keyword using followed by the keyword namespace and then std. These 2 lines allow us access to the functions we need to grab input from the user and then display output back to the user on the screen. Alright, so following our #include statement and our using namespace statement, we're going to begin our main function to the program, which is called int main. This is where work is done. This is where we're going to declare variables, ask the user to supply the inputs, calculate what the output should be, and send the output back to the user on the screen. So I'm going to have int main. I have an open parenthesis followed by a closed parenthesis, and then I have 2 brackets. And in between these 2 brackets is where I'll begin my program. Step 1, I'm going to declare my variables. I'm going to make sure that each variable has a type and a name. So in this case, I'm just going to ask the user to input integers. So I'm going to give my variable a type of int. Notice that int turns blue, letting me know that that's a keyword. And I've already decided what my inputs are going to be called up here. So I can just go ahead and declare them right here. I also know that I'm going to have an output called sum, and that output is also going to be an integer. So I'm going to go ahead and declare my 2 inputs and my 1 output right here with this statement. Next, I am going to ask the user to input the first number. So I need to use a cout statement in order to do that. Cout will display a message on the screen to the user, and this is why we have to include these 2 lines, lines 9 and 10. Otherwise, we can't access the function cout, which allows us to communicate with the user on the screen. So I'm going to ask the user to enter a number. I'm going to end this line with the end line statement, which just moves our mouse or the carriage return here. It moves it to the next line for the user to enter in their number. Now that we've asked the user to enter a number, we have to collect that number from the user. So once the user types in the number on the keyboard, we need to grab that number and store it within one of our variables. In order to do that, I need to use the cin function. And then I need to declare where I want to store the number that the user is going to type in. So I'm going to ask the user to enter a number here. That message is going to display on the screen. And then whatever the user types from that point is going to be stored in num1. I'm going to repeat this for the second number. So I'm going to have another cout statement where I ask the user to enter another number. And I'm going to grab that number and store it in num2. Now I'm going to complete my process where I calculate the sum by adding num1 and num2. This is just an addition. And I can type in my process just like that. So the nice thing about declaring your inputs, outputs, and process first before you start writing your code is you have a clear roadmap. You know what your inputs and outputs are going to be called, and you know how everything is going to be calculated. So when it comes time to actually declare my variables, reference my variables, and then compute my output, I can rely on my roadmap that I started with up here. So my process is just going to be to add the 2 numbers together. And then the last thing I need to do is send the output to the screen so that the user can see the sum. So I'm going to do that. Next, I'm going to use a cout statement where I'm going to tell the user the sum is, whoops, I lost my quote, the sum is, and then I'm going to send the sum to the screen. So this sentence will display the words the sum is, followed by a space, and then whatever value is stored in our variable sum will display on the screen. This is the end of our program. So to end the program, we are going to say return 0. This ends our program. So now that we have everything typed up, we're going to go ahead and debug and look for any errors. So I'm going to do that by hitting the compile button. And I need to save my code. So I am going to do that right here. I'm going to call this one unit 2 example 1 underscore sum. That's going to be the name of my program. So now I'm going to go ahead and compile and see if I need to debug anything. And in this case, I have 0 errors, 0 warnings. So if you were to have an error or a warning, you would need to figure out what's causing that error and go try to solve it. For example, let's say I forget a semicolon right there. If I go to compile, I'm going to get an error, and it's going to tell me on line 19, right here, it's going to say expected initializer before cout. So the error actually isn't on 19, the error is right before. Because there's no semicolon right here, the compiler doesn't know how to compute this next line and what to do with it. We have to end this statement here, this variable declaration, with a semicolon. So if I put that semicolon back in and hit compile, I should see that that error goes away. So now that I have 0 errors and 0 warnings, I am going to run the program and test it and make sure that it works the way we expect it to. So when I hit the run button right here, I am going to get the window that opens up, and I'm now executing my program, and I can see the text that I typed on the screen, enter a number. So as the user, I'm going to go ahead and enter a number. I'm going to enter the number 15. Now I get my second prompt to enter another number. I'm going to enter the number 9. And I get that the sum is 15 plus 9, or 24. So when we write our code, we generally want to test our program at least a few times to make sure that it's working correctly. And this would be my first test. If you are trying this along with me on your computer, go ahead and play around with this program a few more times and make sure that it works the way that you expect it to. Remember, we did design this to just input integers, so if you try to type in a decimal, you might see that it doesn't work the way that you expect it to. And that's because we will work on throughout the semester learning how to error check the user's inputs. Since this is the first unit where you're learning how to write code, we're starting from scratch, and we're not going to worry about if the user enters in something that we don't expect. As long as the user enters in integers, which is what we expect, we should see that the program works correctly and that we get a sum of 24. All right, so now I'm going to move on to our second example for Unit 2. And so I have a new file open, and I'm going to go ahead and start again by typing in the program objective. In this case, we're going to start with the radius in inches and price of a pizza, design an algorithm to find the price of the pizza per square inch. So given the radius in inches and the price of a pizza, design an algorithm to find the price of the pizza per square inch. You may assume that the value of pi is 3.141593. So we'll use that value for pi in our calculations. In your program, declare a constant named pi to store this value. All right, so this is what our program is going to do. Figure out the price of pizza per square inch. So let's talk about inputs and outputs. We're going to need the radius of the pizza. That's going to be something given to us from the user. And then we're going to need the price of the pizza. Those are our two inputs. This program is also going to have a constant. We've been told that we are going to have a constant called pi equals 3.141593. Now keep in mind a constant is a value that cannot be changed throughout the program. Our inputs, like radius and price, those are variables. The user can input a radius of whatever they want to. But the constant pi cannot be changed as we go throughout our program. That number will always be set to 3.141593. Constants are useful when you know you have a given number that's not going to change throughout your program. So we have our constant pi, and then we're going to need our output, which is the price per square inch. That's going to be our output. Now, when you name your output, it's up to you whether you want to use underscores to make it easier to read. If you don't use underscores, then you will want to capitalize every word, starting with the second word in your variable, so that it's easier to read. So you can use underscores, or you can call it price per square inch with capitalization as shown here on the screen. All right, now that we have our inputs, outputs, and constants, let's talk about the process. So now this is the part where we just need to think about, if I had a pencil and a piece of paper or a calculator, how would I figure out the price of the pizza per square inch? Well, in order to figure out the price per square inch, I need to know how many square inches are in the pizza. Well, that would be determined by calculating the area of the pizza. So we're going to have to figure out the area of the pizza, which area of a circle is pi times radius squared, pi r squared. So the first thing we're going to have to do is calculate the area of the pizza. Once we have the area of the pizza, we can calculate price per square inch. By saying the price of the pizza divided by area of the pizza. So this is our process. Step 1, we're going to calculate the area of the pizza by doing pi times radius squared. Then we're going to calculate price per square inch by taking the price of the pizza given to us by the user and dividing by the area of the pizza, which we're calculating right up here. Once we do these two steps, we will have the program objective accomplished. So let's begin our code. Remember, since we're going to be taking input and output from the user, we need to #include IOStream. And we need our using namespace std statement in order to access those input and output functions. Now, we also have to declare a constant because that was part of the program objective. So after we declare our #include and using statements, we're going to add a statement to define pi. We're going to use the keyword constant, C-O-N-S-T, to declare pi. We're going to use all capital letters for constant declarations. That way, as I'm reading through code, anything that's always fully capitalized, it's a reminder that that value is a constant value. So we're going to set pi to be equal to 3.141593. When we define a constant, we also have to give it a type. So integer, double, float, character, whatever it's going to be, we have to define the type. So I have constant, double, and pi. Now keep in mind that your two variable types for decimal numbers are double and float. Float takes up 4 bytes of space. Double takes up 8 bytes of space. Float is for numbers where you don't need that many decimal places for accuracy, and double is when you want to have way more decimal places for higher accuracy. In this case, since we're using the number pi, we want to go ahead and make sure we have a large number of accuracy on our calculations for area and price per square inch, so I'm going to use double to declare our constant pi. Now I can start our main program. So I'm going to begin by declaring my variables. In this case, I have 2 inputs from the user, radius and price. I'm also going to need somewhere to store the area of the pizza once I calculate that area. So I'm going to need to also include double area. That way, I can store the value of area in this variable and use it to calculate the price per square inch. The other thing I need is the output. The output is going to be called price per square inch, so I'm going to declare that as well. And I'm going to go over here and add a comment. These are inputs from the user. This is used to calculate. I can't type today. Calculate the area of the pizza. And this is the output to the user. Use comments to help organize your code. Think about adding comments if you were to provide your code to someone else who had to read through it and understand what you were trying to do. So comments help to clear up any any ideas that were in your head that you want to make sure that anyone else who reads your code understands what you were trying to accomplish. In general, it's always best to start with a program objective at the top with inputs, outputs, and constants if you have any. Define your process, and then use comments to explain perhaps why you're declaring something the way you're declaring it, or what you're trying to do with a particular variable. So now that I have all of my variables declared, we need to obtain the radius from the user. So I'm going to use a cout statement where I ask the user to enter the radius of the pizza in inches. Now I am going to ask the user to type in that information and collect it within CN. And I am going to advance the carriage return, or basically hit enter, after the user has typed in their answer. So I can put a cout statement here, and I can put an end-line statement here. If I do that, this line of text will display, and then it will advance to the next line and allow the user to enter their number on the next line on the screen. Without this, the user enters their answer on the same line that this is displayed, and then we hit enter after. It's more of a preference as to where you put that end line statement. It's up to you where you'd like it to go. Next, I'm going to obtain the price from the user. So we have enter the price of the pizza. I'm going to collect the price, advance to the next line. Now I need to calculate the area of the pizza. So I have that variable area ready to go. I know it's going to be my constant pi times radius squared, which I can type out like that. Pi times radius. Now that I have the area, I'm going to calculate price per square inch. And in order to do that, I have my variable right here, price per square inch equals, and now I'm going to do the price of the pizza divided by the area that we calculated. Lastly, I'm going to display the output to the user. I'm going to add a $sign at the end of my line so that it displays as a amount of money when the output is shown on the screen. So I'm going to put my price per square inch right in there and an end line to advance to the next line. And that completes my program. So I've got the variables declared. I collect the radius from the user, collect the price from the user, calculate the area using the inputs from the user for radius, calculate the price per square inch, and then display that to the user. Let's go ahead and compile and check for any errors. And I'm going to go ahead and save this one as Unit 2, Example 2. All right, so we've got one error. If we look here, my compiler is highlighting line 19. I can read the message and see that it says error expected, comma, or semicolon before int. So if I look right above this line, what did I miss? At the end of this line, I missed a semicolon. So it's not going to compile if you don't have all of your syntax correct. So missing a semicolon, misspelling a variable, things like that, those are called syntax errors. And your program won't run if you have a syntax error. There's another type of error called a logic error, which means your program will run, but it just won't work the way you want it to. So for example, let's say that I had the calculation for area wrong, or I had the price per square inch wrong. I'll get a number that comes out, but it just won't be the right number. Those are logic errors. Your compiler will not detect logic errors. It's up to your brain to figure those out. But syntax errors is why we have a compiler, to find issues like this. So I have fixed this issue with the semicolon. I'm going to compile again. Make sure that it is free of errors. And now I am ready to run the program. So after I hit run, here's the window showing my code. Enter the radius of the pizza in inches. Well, let's say that I get a 12-inch pizza. Usually when you order a pizza from a pizza place, they give you that in diameter. So if I have a diameter of 12 inches, that means I have a radius of 6 inches. And let's say that I got a sale and my pizza was $12.99. There's my price per square inch. So I can see that it's approximately 11 cents per square inch for my pizza. And that is the execution of the code for example number 2. Now I'm going to move on to example number 3. I'm going to go ahead and start a new window here, and I'm going to just go ahead and save it first. And I'm going to call this one is example 3, and this one's going to be called grades. All right. I'll begin with the program objective. So we have a student's grades in a class are determined as follows. The midterm is 25%. The final exam is 25%. There's a research paper that is 20%. A group project that is 20%. And participation in the class is 10%. We are going to write a program to input each of the students' scores for each of the 5 grade components. Calculate the class grade based on the percentage assigned to each item. So we're going to basically become a grade calculator based off of these weighted grades. So let's talk about inputs. We're going to need to collect 5 grades. So let's call them midterm grade, final grade, research paper grade, group project grade, and participation grade. Notice that I'm picking names for my inputs that very clearly explain what they are. I don't want to use names like A, B, C, D, E, and F because I'm not going to have a clear connection to what each of those names means when it comes to what my program is trying to do. So make sure that as you choose your names for your inputs and your outputs, they do connect to what they actually are supposed to represent within your program. So these are our inputs. I'll take that out because I can copy and paste this later. All right, so those are our inputs. I'm going to go ahead and define the weights as constants. And that is because each one of these we don't expect to change. And if we do expect them to change, it's easy to change a constant and recompile later. But let's say that I had to use these percentages in my program 50 different times. If midterm exam changes from 25% to 20%, do I want to go and change that 50 different times within my code? No. But if I use a constant, I can just change the value of that constant once. And then everywhere else that that constant is used in my program, that change will automatically be reflected. So that's a usefulness of constants. So I'm going to go ahead and create some constants. I'm going to call them midterm weight, final weight, research paper weight, group project weight, and participation weight. And I'm going to make sure that when I declare these constants, they are going to have the percentages described right here in the objective. Next, I am going to define my output, which is going to be the grade you get in the class, or class grade. And then what's my process going to be? Well, in order to get a class grade, I have to multiply each individual grade by its weight, and then sum all of those together. So I'm essentially going to be doing midterm grade times midterm weight. And I'm going to use some spaces here to make it really clear what I'm doing. You don't have to put it all on one line. As long as I don't end the line with a semicolon, that same line is just continuing forward. So I'm going to hit enter and do plus on the next line just so that it's clear each piece of the calculation that I'm doing. Next we have final grade times final weight plus research paper grade times research paper weight plus group project grade times group project weight plus participation grade times participation weight. So that's going to be the calculation I use to determine the class grade. Now I'm ready to start my program, now that I have my objective, my inputs, my constants, my output, and my process for how I'm going to find the output. Now I'm ready to start typing my code. So we're going to have our pound include statement. Our namespace statement. And then we're going to declare those constants. All right, so I listed them right up here. I'm going to copy and paste. And each constant I'm going to call a float because I'm not expecting more than 2 decimal places for these grades. So I don't need a lot of precision. I'm going to use floats for these. So the midterm weight is type float and it's 25%. The final weight is also 25%. Keep in mind I'm writing these as a percent, as a percent that I'm writing in decimal form. We have constant float research paper weight. That's 20%. Nope, I misspelled float right there. Constant float. We have group project weight. That's also 20%. And then we have participation weight is 10%. So these are my constants. For my program. Now I'm ready to start the main function. Let's go ahead and declare our variables. In this case, if I go back up here, these are my inputs. I can copy. Oops, sorry. We're going to call these all floats. Okay, so there's my inputs. My output is going to be class grade. Now I'm ready to ask the user to input each grade. So I'm going to have 5 cout statements followed by a cin statement where I collect these 5 inputs one by one. I'm going to go ahead, copy paste this line here, and just change the last part. So after final exam, we have research paper. Then we have group project. And then we have participation. Now we need to go ahead and calculate that class grade, which I've got right here. There's my calculation. So again, the nice thing about figuring out your process and your inputs and outputs before you start writing code is that you have a nice, clear place to go back to when you actually are ready to implement your ideas in the main function. And so while you clean up your ideas up here, once you have a clear picture of what you're doing, it becomes very easy to see what goes where, how to name everything, and where your calculations go. So because I've already cleared the path or made a roadmap for what I want, I've already got my calculation ready to go. And I can copy and paste that down here when I'm ready to calculate the final grade. So class grade equals midterm grade times midterm weight plus each one of these and so on. And I just need to add a semicolon at the end and my grade is calculated. Now I need to display that to the user. So we'll say class grade. And then we're going to send the class grade. And that's the end of our program. All right, now we're ready to compile, debug as needed, and then run the program. So let's go ahead and hit that compile button. And let's see what we have here. Error. Research paper grade was not declared in the scope. So if you see an error like that, that typically means that the variable name you're using has not been defined. If we look very, very closely, see if you can figure out what mistake I made. Research is spelled wrong. So if you look up here, I spelled research correctly here. I did not spell it correctly right here. So I'm going to go ahead and copy paste to make sure that research is now spelled correctly. And I also misspelled it when I was writing my process. So misspellings happen. I'm showing mistakes intentionally so that you know how to deal with them whenever you make the same mistakes. So I misspelled something. Sometimes you'll have to look for that when you get an error after trying to compile. So let's compile again. All right, I have 0 errors. Now I am ready to run the program by going right up here and hitting run. So now my program is running and let's type in some data to test it out. Let's say that I get a 96 on the midterm exam. Let's say the final exam grade was an 84. Let's say that the research paper grade was a 77. And the group project grade was a 92. And then let's say that I got 100% as my participation grade. I now can see my class grade displayed at the bottom, which is an 88.8%. And that 88 reflects all of the weights that we entered into our code for each one of these categories within the grading scheme. So this grading scheme is used obviously in many classes that you've seen probably in high school and in your college work, and this is how that grade is actually created. So we can see that the program meets the objective by taking in each of these grades, applying the weights provided, and then providing the final class grade. So just keep in mind that the usefulness of the constants that we put into this program are that, let's say that we change the grading scheme so that we want the research project to weigh more or the group project to weigh less. we can simply change our values right here in our code, rerun the code, and we'll see that reflected in the final output with that weighted class grade. So that is the third and final example for this video. Thank you for watching. Please email me if you have any questions, and I will see you guys next time.